Hello Math 130 students. Welcome to week 3. I went ahead and created kind of like a recap of chapter 1. So hopefully you're working on the Newton, which is the homework, by going into modules and logging into the homework assignments and working on these problems. Hopefully you have already finished, but if not, you do have the deadline to finish all homework. So the deadline to finish all the homework is going to be on June 6th. But we do have our soft deadlines. And these are more of benchmarks for students to reach throughout the semester, so that way they don't fall behind. So even though you may have a 0 on Canvas, just know that you can log in, complete the assignment, and still get full credit as long as you finish by June 6th. We just want to make sure that you see that all of these grades affect your overall standing in this class. And we want to make sure that you just kind of get caught up in the loop of things and don't fall too far behind. And also you will have your first math video available on March 1st, and that's in 2 weeks from now. So that's going to be in week 5. For number 1, it says classify the equation as a conditional equation, an identity, or a contradiction. So what you're going to have to do is make sure that you understand the vocabulary here. So what is a conditional equation? So a conditional equation is when you have one unique answer. Okay. So now if I go to, let's say, identity, the identity is making sure that you know that if you have the same number equal to the exact same number, then this is really going to be all real solutions. And our next definition is contradiction. And a contradiction is saying, let's say two different numbers are the same. So if I have -3, that is the same as 7, which is not true. This is false. So this is not real, or no solution. The answer here doesn't make sense. So let's see what happens when you're looking at this particular problem. So I have 50z plus 18 is equal to 8 times 6z minus 7 plus 2z plus 74. So what I want to go ahead and do is just kind of make sure that I distribute this positive 8 inside my parentheses. So everything else is going to get copied down. So I'm going to go ahead and rewrite the equation over here. So I have my 50z plus 18 is equal to 8. 6z minus 7 plus 2z plus 74. Okay, and like I said, I'm going to take that very first 8 and distribute inside my parentheses. Everything else is going to stay the same. So I have my 50z plus 18 is equal to, and this is where I'm distributing the 8, so that 8 times 6 is going to give me a 48z, and an 8 times 7 is going to give me a 56. So here what you can do, and you don't have to do this step, but I'm going to rearrange it so that I can see that I have z's that I can add up together here. So I'm going to have 50z plus 18 is going to equal to my 48z plus my 2z, and I'm left with a negative 56 plus 74. So combining like terms, 48z plus my 2z is going to give me 50z. And if I combine my negative 56 and 74, I would get a 18. So I know that these two numbers combine together and these two numbers combine together. So now we can see that we actually have the same thing on both sides. So what we can do is we can subtract each term, but since they're the exact same thing, everything's going to be the same. So here I do have 18 is equal to 18. Then I can go ahead and say that I have the same number equal on both sides, so that situation must be the identity. So what type of equation is this? So the classification would be identity. So it wouldn't be conditional and it wouldn't be a contradiction. The answer here would be it was an identity. And that would be my final answer. Now, looking at the Pythagoras Theorem, now if we look at the second problem here, it says use the Pythagorean theorem to find the length of the hypotenuse in the triangle shown below. So here what's really helpful is it's telling us what to use. So if I have the Pythagoras theorem, then I know that that tells me that I have a squared plus b squared is equal to my c squared. And you might be wondering, okay, well if I have this Pythagoras theorem, what does the a, the b, and the c stand for? Well, this would be one leg of this triangle squared plus the other leg of the triangle squared is equal to the hypotenuse squared. So you might be wondering, well, where is the hypotenuse? The hypotenuse is always directly across from that 90-degree angle. So that little square tells you that it's 90 degrees. And right across from that 90-degree angle inside the triangle, it gives us the hypotenuse. So then I go ahead and plug in numbers. So I would have a 16 squared plus a 30 squared is equal to the hypotenuse squared. Well, I don't know what the hypotenuse is. So we can just go ahead and give it a variable. So if I have 16 squared, that's going to give me 256. And if I have 30 squared, that's going to give me 900. And let's call the hypotenuse c. So if I add those together, I will get that this is going to be 1156 is equal to a c squared. The only way to get rid of a degree 2, so this is an exponent of 2, so if we're trying to get rid of an exponent of 2, we can square root both sides. So now I have the square root of 1156 is equal to a c. Because what ended up happening is that square root and the square cancels each other out. So now if I just plug this into my calculator, the square root of 1156, I'm going to get 34 is equal to c. So since my c is equal to 34, I know that my hypotenuse in this triangle that was given is equal to 34. And so that would be my final answer. Alright, so looking at the next example, what do we have? We have a word problem, and it reads, Lee has $1.75 in dimes and nickels. The number of nickels is 11 more than the number of dimes. How many of each coin does he have? So hopefully you know how much money So hopefully for this problem, we understand the value of dimes and nickels, at least in America. You might be an international student, or maybe you just don't use coins that often, but we do have a value for each coin. So the value for each coin, well, if I have a dime, it's going to be 0.10 cents. And if I have a nickel, its value or its worth is 0.5 cents. Okay. Now I know that I have a total amount of value. This 175 would be my total value. And it's consisting of nickels and dimes. So what is it really telling us? It's telling us the amount of nickels plus the amount of dimes is going to equal my total value. So if I add up the total amount of nickels and add up the total amount of dimes plus their worth, then it's going to give me my total value. And that total value that I have is $1.75. So what do we know about nickels? Well, let's go ahead and give nickels a variable. Let's give it an n. And dimes, let's give that a variable and give it a d. So I know that I'm combining nickels and I'm combining dimes as well. Now, what you're going to have to do is put the value of each one right in front of the variable. So here, how much is a nickel worth? Well, remember, we already defined it over here, how much the value of a nickel is. Well, we know that to be 5 cents. Then we talk about the value of a dime. Well, we talked about the dime and the value, and we knew it was a 0.10. So now, if I read that second sentence, that's how we're going to get our second equation. So it says the number of nickels is 11 more than the number of dimes. So we have to translate that into a mathematical equation. So that word is, you can always think of that as an equals. So equal sign. We can think of is, and another good word that to think of is also be was. So is or was in a word problem involving math will translate to an equal sign. So now if I have the number of nickels, so we're talking about n, because that's the variable we use for nickels, is, so that's going to be equals to 11 more than. But we know that more than is really translates to just adding, right? That's just going to be a subtraction. So I have 11 plus, and it says the number of dimes. Well, dimes we didn't know, so we called that D. So now I have my second equation. So that means that if I have n over here, then I can plug it in for this n over here. So now I'm going to get a 0.05. And now that variable, or that equation, I'm going to write in an 11 plus d. And I still have a 0.10 d is equal to 175. So now when I distribute, I would get a 0.55 plus 0.05d plus 0.10d is equal to 175. So if I were to go ahead and add those two values together, I would get 15d, and we still have that 0.55 is equal to 175. So then from there, you could subtract 0.55 from both sides, so that you have a 0.15d is equal to 1.2, and from there, to get the d by itself, you divide by 0.15. So you'd get that d is equal to 8. So what does the d represent? That represents the amount of dimes. So how many dimes do you have? You have 8. So if it's saying how much of each coin does he have, well, remember I was talking about dimes and nickels. So you also have to include in your final answer the amount of nickels. But remember, nickels, you already had the equation for nickels up on top. You previously had that n is equal to 11 plus d. So n is equal to 11. And remember, you found the d value to be 8. So that n is equal to 19. So how many nickels do you have? You have 19 nickels. So the next word problem reads, a church luncheon made $842. Adult tickets cost $10 each and children tickets cost $6 each. The number of children was 12 more than twice the number of adults. How many of each ticket were sold? So if you want to think about it, we want to understand how many of each ticket was sold. So what type of tickets did we have to sell? Well, we had the adult tickets and we had the children tickets. So that is the types of tickets that we have. So then we have my adults. So let's just go ahead and organize my information. It's going to cost $10, and for each child ticket, it's going to cost $6. So we know that a combination of these two types of tickets gave us $842. So combination of my adult tickets plus my child ticket is going to equal my total value. And here we have our total value of that 842. So I know all of this is going to equal to my 842. So let's think about this. We have my adult tickets. Let's go ahead and call that A. And we have my child ticket, so let's go ahead and call that C. So we have my A plus your C is equal to your 842. Don't forget that we have to put the value out in front. So here the value of each adult ticket was $10. The value of each child ticket was $6. So now we're going to get our second equation from our second sentence here. The number of children was 12 more than twice the number of adults. So we're going to go ahead and translate that. So here that was is my equals. And the children, remember, we called C. So the children, C, equals 12 more than, but we know that more than just means to add. So we had 12 plus, because we have that more than, And twice the number of adults, well, twice something is 2 times something. And here the adults we are calling A. So we have C is equal to 12 plus, since it's 12 more than, twice the number of adults. So now we have our 2A. So now whenever I see that variable C, I can go ahead and plug in this equation here. So I'm going to have 10A plus 6, and here's that equation, which was 12 plus 2A is equal to 842. Now I would have 10A plus, and I would distribute that 6 to give me 72 plus 12A is equal to 842. And I would go ahead and combine my A's. So I would go ahead and get a 22A plus 72 is equal to 842. Now I would subtract 72 from both sides and get my 22A is equal to 770, and divide by 22 to get the variable by itself. So then A is equal to, and that 770 divided by 22, when you plug that into your calculator, you're going to get 35. So the amount of adult tickets was 35. And remember, we want each ticket, so that includes the adults and the child. So now we have to find the amount of children tickets. Well, we already have our equation. Remember, our equation that we had was C is equal to 12 plus 2A. And we already found the amount of the adult tickets. That was 35. So then your C value is going to equal to 82. So you have 82 children tickets. So your next problem reads, 2 buses leave Billings at the same time. The Seattle bus heads west on I-90 at a speed of 73 miles per hour, while the Chicago bus heads east at a speed of 79 miles an hour. How many hours will it take them to be 532 miles apart? Well, we know that our home base is Billings here. So I'm not the best drawer. Let's just go ahead and call this the start. So you started at Billings. So we have 2 buses, and here they leave at the same time. Now, the first bus, let's go ahead and call it the Seattle bus. Well, for the Seattle bus, it has a speed of 73 miles per hour, and it's heading west. So I know from my starting place, I'm heading out towards the west, and I'm heading towards Seattle, and the rate is 73. Since I have miles per hour, that gives me my rate. Now, for my next equation, it says that you have your Chicago bus, and it's going at a rate of 79 miles per hour. And this one is definitely heading east. So, it starts at the same place, but this one is heading east, and is going towards Chicago. And its rate is 79 miles per hour. And these are buses going in different opposite directions, but starting at the same place, like the bus station. So what's going on in this problem? Well, this type of problem is a motion problem. And from this motion problem, we know that this is a distance is equal to my rate multiplied by my time. Okay. So the only piece of information I'm really missing here is that here I have the same time. So we don't know what the time is. That's what we're trying to figure out. Since it says how many hours will it take them. So my hours, my time is unknown. That's what I'm trying to figure out, okay? And we have the total distance between them. And the reason we have the total distance between them is because it's 532 miles apart. So if that's the case, I can go ahead and start kind of filling in some of these values. So I'm just going to modify that equation just a little bit since we are talking about two different buses. So the distance between both buses would be equal to that first bus. So let's call this the Seattle bus, where you have your rate times your time, and you're going to add to it your Chicago bus, and you're going to figure out your rate and your time and plug in those values. Okay, so now that I'm dealing with two different buses, then I'm different with two different rates and do different times corresponding to each bus. So now if I just plug in my values, the distance between both buses, well, I had my total distance between the bus as 532. So I have 532 is the distance between both buses. The Seattle bus, well, I know that that rate was 73 because it said rate is equal to 73, and it's being multiplied by the time. And here time is unknown, and I said that time was going to equal to t. And my Chicago bus here, I have my rate, which was my 79, and it's also going to have t for time, since they both travel the same amount of time, right? It specifically says that it would be the same time. So when I really have my equation, when I'm thinking about it, I have 532 is equal to a 73t plus a 79t. So I can go ahead and just add these together. So that 73t plus 79t is going to equal to 152t. And divide out by the coefficient to get t by itself, then I would get 3.5 is equal to t. So the amount of time that they both drive would be 3.5 hours. And that would be my final answer. So for my next problem, it states, express the inequality -8 is less than x less than or equal to 3 using interval notation. So the key word here is interval notation. So just a little side note, whenever you're thinking about your interval notation, you're always going to be finding the minimum value and your maximum value. And it's either going to have parentheses or brackets, or a combination of parentheses and brackets. Okay. Kind of just depends on the situation. So here I have x and it's going to be in the middle. So I like to be a visual person. So I know on one end I have a -8, and the other end I have a +3. So here, if I'm looking at this -8, I know if I look at this inequality, this tells me it's going to be using parentheses, which translates to an open circle on the graph. Now, if I'm looking at my other value, it's saying that x is less than or equal to a +3. So looking at the inequality itself, it's telling me that I'm going to be using a bracket. So if I'm going to be using a bracket, I can translate that as a filled in closed circle. And it's saying that x is between these two values. So it's going to be bigger than -8, and it's going to be smaller than a +3. So for me, that visualization is helpful, but it's not necessarily helpful for everybody. Here you can go directly into the interval notation. So if I'm looking at the interval notation, remember I'm thinking about either parentheses, brackets, or a combination of either. So I know that the minimum value is a -8, and that my maximum value is a +3. So if I'm looking to write my interval notation, I have a -8 and a +3. And because I have a -8 and the inequality tells me I'm going to be using a parentheses, versus that +3, the inequality is telling me to use a bracket. So then that would be my answer in interval notation. For the next problem, it says solve 2x minus 1 less than 4 and -5x minus 3 greater than -3, and write the solution in interval notation. If there is no solution, type a circle with a line through it. So here, before we go any further, I want to make sure that you understand the importance and the significance of that word here, which is and, okay? So if I have and in an inequality problem, that is going to translate to the intersection. If I have the intersection, you can think about that as what they have in common or what's overlapping. And so it all comes from that word and. So I need to work out each kind of inequality and figure that out. So if I have my 2x minus 1 less than 4, I'm going to go ahead and write that out. So the first equation that I'm going to have is 2x minus 1 less than 4. And the second equation I'm going to have separately is -5x minus 3 greater than a -3. So I'm going to work out each problem individually. So I'm going to add 1 to both sides. So then I can get 2x is less than 5. And here I would divide by 2, so that x is less than a 5/2. Now, if I look at the second equation, I'm going to go ahead and add 3 to both sides to solve, so that a -5x is going to be greater than, and here -3 plus 3 is going to be a 0. The next step I'm going to do is go ahead and divide by a -5. So I get x is greater than 0. But remember, whenever you divide by a negative number, the inequality is going to change direction. Okay? So So now it's going to be x is going to be less than 0. So the visualization, so the visual with the graph, I know that I have a 0 and I have a positive 5/2. So the green equation is telling me that x is going to be less than 5/2. Okay. From my blue equation, it's telling me that x is going to be less than 0. Okay. So the key word here was and. So I'm looking for the overlap. Since this is the intersection. So then the intersection would be everything here. And where does that go off to? It goes off to negative infinity. And of course this side goes off to positive infinity. So the overlap, if I'm thinking about my smallest value, is negative infinity. And negative infinity or positive infinity will always have a parentheses. And the overlap is going to stop at 0. And 0 was x is less than 0. So the inequality itself tells you it's going to be a parentheses. So then this would be my answer in interval notation. So this next example, we still have inequality, but now the keyword here is or. So if I'm looking at or, that really means the union. So I'm really going to be thinking about everything. So I'm going to go ahead and work out each side just like I did before. So the first equation that I have is a negative 3x over 4 less than 3. And the second equation that I have would be a 4x plus 6 less than a negative 3. So let's look at that green equation. The very first thing that I would do is multiply by 4 on both sides to get rid of the fraction. So I would have a negative 3x is less than 12. Now I would divide by negative 3 on both sides. And 12 divided by 3 is a negative 4. And because I divided by a negative number, I'm going to change the direction of inequality. So now I have that x is greater than negative 4. Now looking at the blue equation, I'm going to go ahead, I'm going to subtract 6 from both sides. So that we have 4x is less than negative 9. And I can go ahead and divide 4 from both sides. So the x is going to be less than a negative 9/4. So again, if you want to just think about the visual, I'll have a negative 9/4 and I have a negative 4. Right? And we have like 0 over here, and let's say like, I don't know, negative 10 over here. And of course this goes off to negative infinity, and this can go off to a positive infinity. So now if I'm looking at that green inequality, saying x is going to be greater than negative 4, then at negative 4, it's everything greater. If I look at that blue equation, at negative 9/4 here, or better yet, here, negative 9/4 is everything less than. So that's going in this direction. So if I'm thinking about that or, which I said was the union, and you think about everything, well, everything that's blue and everything that's green, well, that goes forever and ever in both directions on the number line. So it's all round numbers. So because I had union, my integral notation goes from negative infinity to a positive infinity. And that would be my final answer. For the next problem, what's different about this is now you're dealing with the absolute value. So if you're wondering how I'm doing these problems, go back to the YouTube videos that I have. And remember, these are located in Canvas in case you have forgotten. They're on the home page. If you click on YouTube videos, that's all the lecture videos that we have. And on chapter 1, if you go to the PDF that's attached, if you go to page 26, it gives you all of the rules for the absolute values. So if you need to review, that's where I would review specifically. So go back to the lecture notes. And from the lecture notes, go to chapter 1, page 26. And you can either see the PDF or you can see the YouTube videos, whichever you would like, that speaks a little bit more in depth about these absolute values. So to continue with this particular problem, we have the absolute value 5x minus 5 plus 9 is less than a positive 8. So then here, remember, you have to isolate the absolute value first before you do anything. Okay. And then from there, once the absolute value is isolated, then you can apply the rules. And remember, the rules you can find in the lecture notes. Chapter 1, page 26. And this particular rule, if you look at it, tells me that I'm going to have a no solution. Right? The absolute value cannot be less than a negative number because that distance can never be negative. So again, just go to the videos or those lecture notes and you can see that. So for our next problem, we still have an absolute value inequality. So let's see what we have. Here now I have a 3w over 5 minus 7. Minus 7 is equal to a negative 2. So here, to isolate the absolute value, I'm going to go ahead and add 7 to both sides. So I have the absolute value of 3w over 5 minus 7 is equal to a negative 2 plus 7. Well, that's going to give me a positive 5. So now that I have the absolute values equal to a positive number, I know because of the rules of absolute values equations that you have to split this into two problems. And remember, that comes from chapter 1, page 26, if you need more review. So the first equation I'm going to have is a 3w over 5 minus 7 is equal to 5. And my second equation, I'm going to have a 3w over 5 minus 7 is equal to a negative 5. So the only difference between them is a 5 and a negative 5. So now, if I were to solve this first one by itself, I would go ahead and get my 20 is equal to w. And if I went ahead and got w by itself for my second equation, I would get that 10 over 3 is equal to w. So those would be my final answer. The 20 is equal to w, and 10 over 3 is equal to my w. And that is the end of the recap of Chapter 1. So I hope this video helped. Thank you.